Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members into our discussion for today, and kindly request for those of us who have not subscribed, kindly do so. Engage us in the comment section and also ring that notification bell for different updates on our different discussions. Now, in our discussion today, I'm going to look at the concept of curve sketching. And we're going to look at some of the conditions which are necessary for us to obtain this specific, or rather to perform this aspect of curve sketching. And this is going to be, of course, a range of ideas which we have discussed under the concept of a critical point, the various range of the mean value theorem, the intermediate value theorem, Arrow's theorem, and some of the critical points. Now, in our application today, I'm going to look at some of the conditions which are going to be useful for us, or the information which we're going to need for us to obtain this specific aspect, or to perform this aspect of curve sketching. And this is going to be identification of what we refer to as the concept of symmetry. And in a sense, we're going to see that for us to define this concept of symmetry, I've mentioned in my previous videos about the concept of odd and even functions, which we can basically define in terms of this specific representation of a function of f of x given as such. And this is going to be giving us what we refer to as even functions. So for all the values of the domain of x given in this specific function of x given as such, we're going to see that such a kind of a function are going to be referred to as even functions, which are going to be obeying this specific, of course, condition which I have given. And as well, we're going to see that if we have a function which are going to obey these specific conditions for all the, of course, values of x in the domain of that specific function, these are going to be given in terms of negative, the function of f of x given as such. And these are going to be giving us what we refer to as odd functions. Now, in a sense, we're going to see that in this specific category of functions, there are other functions which are going to be forming a combination of two, specifically which are going to be having a line of symmetry either along the x or y axis. So in this particular case, then therefore, we are going to consider these two specific types of graphs which are given for odd and even to be symmetrical. And of course, we're going to have that one discussion in our different videos which we are going to come across. So in a sense, this is going to have an implication that for every point that we're going to have perhaps in this specific description for the, perhaps this is going to be x and of course y. So if we have a particular point which can be given in terms of c, then we're going to have x given as such, and y at this specific point. So we're going to have the, of course, coordinates for c given as x and y. And in this particular case, we're going to have an opposite corresponding point, which is going to be given in terms of this specific, of course, negative x. And of course, we're going to have y given as such. So such a kind of points are going to be having some lines of symmetry that cross or down the y-axis and across the x-axis given as such. And of course, I'm just going to limit that one at such a point. So for us to sketch this particular function, we need to have a knowledge of the concept of symmetry. And for that specific case, we are going also to see that we need to have a knowledge of the critical points, which we have extensively done, particularly for the stationary points in our previous videos, and the points of inflection. And as well, we're going to see that we need to have a knowledge of the regions of rising or regions of increase and decreasing sections of the curve, which I have also done. So in this specific case, we're going on to see that we require that specific knowledge for us to perform the concept of curve sketching. So we need also to know what we refer to as asymptotes and asymptotic curves. Asymptotic curves. We've also looked at the concept of asymptotes, which we said these are going to be basically lines of course, curves which are going not going to meet however close they come to this specific, of course, a line or axis. And in a sense, we had described the concept of horizontal, of course, horizontal skew and other types of course, asymptotes in our previous video. So kindly check our description boxes for a link which is going to be assisting us try to identify these particular videos, and they're going to assist us. So apart from having the knowledge of asymptotes and asymptotic curves, we're just going to be required to identify the points of inflection for the horizontal, for the rising, and of course falling curves, which we have already done in some of our video. So this is going to be points of inflection, which we have already looked at, and what we refer to as a concavity. And this specific case, concavity refers to if we have a critical point at this specific point, we're going to have what we refer to as that specific kind of a curve going as such. And if we have another critical point at this specific point, we're going to have another, of course, a concave kind of a graph or a function given as such. So we're going to either to have an up or down kind of a concavity. And in a sense, for us to describe this specific kind of a curve sketching, we need some of the knowledge for us to interpret these specific curves of the points of inflection and concavity. And lastly, we're going to see that we can as well need to identify what we refer to as special points, which are going to be points, of course, of intersection with the curves, points of or special points, which are going to be points of intersections with the various axes, which we have just mentioned for the two Cartesian coordinate system, which we have been consistently been using as our point of reference. Now, in this particular case, I'm going to consider this specific function. Having mentioned that we are going to require this, of course, a set of knowledge for us to do this concept of curve sketching. And therefore, in some of my, of course, not all of them, but some of them, of course, are going to be applicable in this specific evaluation. Sorry for that. Now I'm going to, of course, perform this specific concept of a curve sketching for this particular curve by identifying a various range of the specific concepts which I've just mentioned in this particular case. So the first step for us to, of course, evaluate this one, we're going to require to determine the intercepts. These are going to be the x and y intercepts in this particular case. So at the intercept, each respective, of course, discretion for the variables of x and y are going to be considered to be 0. So in this particular case, if we have a y given as a 0, then we're going to have this specific, of course, graph given in terms of 0 is equivalent to 3 plus 2x minus x squared. So we're going to solve for the value of x. So we can use different strategies in trying to find this, and among them, of course, I've mentioned the concept of completing squares from some of our basic mathematics evaluation. Now we're going to do a rearrangement of this one according to the degree of this equation, whereby we're going to have x negative x squared given as such, and then we're going to have x, and then we are going to have a plus 3 given as such, equivalent to 0. Now we're going to perform a method of completing the square and try to see what are some of the, of course, implication of this. So we shall have negative x squared plus 2x. So remember, this is an equation of the form ax squared plus bx plus c, which we have said is going to be basically equivalent to 0 for the y-intercept. So in a sense, we're going to complete the square of this one by taking this element of b over 2 and we square that, and we're going to perform the same operation on both sides of the equation. And therefore this one has an implication that we're going to have this one plus. So the value for b in our specific case for this general representation is going to be represented by 2. So we shall have 2 over 2, the square of that, equivalent to. So we shall take this value of a c on the equal sign, and then it's going to be having a negative value, negative 3 plus this specific value of a b all over 2 the square of that. So we have just done the same operation on both sides of the equation, and therefore we are going to maintain its specific, of course, a form. So in a sense, this is going to be reducing to a form of x, which is basically going to be a negative. So I just put it in an elaborate way. So we're going to have a negative x plus, of course, this value of a 2 over 2 squared. And 2 over 2 is going to be giving us a value of 1. So this is equivalent to negative 3 plus 1 given as such. So this is going to imply that we are going to have this 1 minus x as this specific. So this is just a rearrangement of this specific, of course, linear form of the equation, which is going to be giving us the square of either this specific. So we shall have a square root is going to be either positive or negative, the value of negative 2. So this is going to be the value of negative 2 given as such. So this is going to be having an implication that we can have this specific equation given in the form of this. So just a minute, there's something I just like to confirm. So perhaps we can consider taking this approach whereby I'll have this one just given as such, and this is going to be given as 2. So in doing our evaluation, we are going to simplify this equation given as 2x plus 1 is equivalent to negative 3 plus 1 given as such. And this is going to be reducing to a form of the equation of negative x squared, and then we shall have this one plus 2x is equivalent to negative 3. So this 1 and 1, of course, are going to be cancelling out. I'm going to take this one on the other side. So this implies that basically we can rearrange this equation and divide by the negative sign and have x squared minus 2x. So we shall have 2x at this specific point, and then minus 3 is equivalent to 0. So in this specific case, we can as well rearrange and solve this particular equation. So the quadratic equation we are going to have in this specific case, we are going to do a rearrangement and try to solve, where we shall have 2 minus these specific values of so the coefficient of px can be evaluated by having this specific set of numbers for x and 3x. So these are going to be giving us in totality a negative 2x, which is going to be given as such, and then we shall have 3 which is equivalent to 0. So the left hand side of the equation can still be given in terms of this specific set, whereby we're going to have x plus 1 into, and then this is going to be basically, so for that one we're going to have a negative 3, so we shall have this one as a negative value of the common factor. In this specific case is going to be 3, so that one is as well going to give us x plus 1 is equivalent to 0. So we're going to take the factors of these two specific representation for the x plus 1 and x minus 3 as the factors of this particular equation. So giving us the value of x is equivalent to negative 1 or positive 3, x is equals to 3 given as such. So in a sense, we are going to see that for an intercept of the y is equivalent to 0, that's going to be giving us these two specific values. And whenever we're going to have of course, a value of x equivalent to 0, so in this case, we're going to have this specific for the y-intercept, and then we're going to have this one equivalent to 0, and then y is equivalent to, so this is going to be 0, 0, 3, so y is equivalent to 3. So if you were to look at the specific, of course, coordinates for this specific particular graphs, we have identified what we refer to as the intercept. Then the next case, we're going to see that we're going to identify the asymptotes, which can be given in terms of these specific graphs. And we said that the asymptotes are going to be lines which are going to be approaching a line. Of course, as we can see, there's none from this specific case. And we're going to determine what we refer to as stationary points. So number 2, I've said asymptotes, as we had mentioned, for one of the conditions which are required. So in this case, there's no asymptote in this specific curve. And then we're going to see that we're going to determine what we refer to as stationary points. And in this case, we had said that for stationary points, we're going to have the f prime over x equivalent to 0. So we shall perform an evaluation for us to obtain the f prime over x, whereby, as I've said, perhaps I can just go away with this. Since we have found the values of this particular x for the intercept, as we said, for this one, this implies that x is equivalent to negative 1 or x is equivalent to positive 3. And for the x equivalent to 0 for this intercept, we're going to have y equivalent to 3 given as such. So this is the information that we need. And then we shall look at the concept of the, of course, this stationary point, which we have said is equivalent to the first derivative, giving us a 0. So we shall have this equation which is given as y is equivalent to 3 plus 2x minus x squared. So this f prime over x is equivalent to, of course, we're going to have 2 minus 2x given as such, and this is going to be equivalent to our 0. So we're going to have this one given in terms of 2 minus 2x, whereby our x is basically the value of 1. And therefore, at 1, we are going to have this specific aspect of the coefficient, or rather the first derivative of this one given as a stationary point. And therefore, if you consider the x and y axis for this particular representation, we shall have this one given in terms of a 0, 1, 2, 3, 4, -1, -2, 1, 2, 3, 4, -1, -2. So let's consider the x and y. I try to see how we can sketch this particular curve, whereby we're going to have a coordinate of the first set, whereby if we have y equivalent to 0, so we shall have a range of coordinates given in terms of x and y. So whenever y is equivalent to 0, we're going to have a corresponding value of -1 given as such. And this is going to be giving us an implication that if we have y as 0, there's a point given at that particular point. And if we have basically y equivalent to 0 still, we're going to have another point given as a positive, of course, which is going to be a positive 3. And of course, we're going to have this specific value for x. So whenever y is equivalent to 0, the x is going to be a positive 3 given as such, which is going to be positive 3. And whenever we're going to have x equivalent to 0, we're going to have y equivalent to 3. So this is going to be x equivalent to 0, y is equivalent to 3 given as such. So in this case, we're going to see that for us to identify these particular solutions, we have said that we're going to have this specific, at x is equivalent to 1, we're going to have a maximum point given at such a point. So therefore, this is going to be equivalent to this one, whereby we're going to have, whenever the value of this specific function is equivalent to positive 1, we're going to have this specific value of, so just a minute, the maximum value given in terms of 1. So this curve is going to be given in terms of this specific representation that is going to be appearing in this particular form. Of course, this is going to pass through the point, not just the way I've just given. So this is how roughly we can sketch this particular curve of the function which we have defined. And this is going to be constituting the aspect of what we refer to as a curve sketching. Now, in a sense, we had said, of course, that we're going to have this specific stationary point, and we can perhaps make a clarity on the same. So we're going to have a stationary point at 1, but in this case we said that for us to have a stationary point at 1, the value of x is going to be equivalent to 1. To have a stationary point, the value of x in this equation is going to be equivalent to 1. So we're going to perform a substitution in this case, whereby we are going to have f of 1 is equivalent to 3 plus 2 into 1 minus the square of 1 given as such. So this is going to be giving us the value of the function equivalent to 4. And therefore, we're going to see that basically this is not going to be equivalent to. So in order for us to find a stationary point, this was a procedure for obtaining this particular value for x. And therefore, the value for x of this specific function at a stationary point is equivalent to 4. So that we are going to perform that specific, of course, change in that. And this is going to be assisting us to create a clarity for that. So whenever we're going to have the value of x is equivalent to 1, the function is going to assume a value of 4 given as such. And this is going to be performing what our, of course, a stationary point is. So we are going to include that one in this, that the value of the function is equivalent to 4, then x is equivalent to 1 start. And this is going to be forming our maximum point. So we're going to have the various range of coordinates for this. And the graph is going to be passing through these specific points which we have just described, and of course going to do that. So that's going to be the correct way of representing this specific curve in curve sketching, and kindly make that a specific correction. So kindly check our description boxes for various links of other videos, engage us in the comment section, and also ring that notification bell for other updates. So that is it for now, guys. By God, please. We catch us in our next video.